Hey everyone, in this video, we will be learning about hexadecimal numbers. So hexadecimal is base 16. So that means there are 16 digits in hexadecimal. So you have you have 0 to 15. But you might be thinking, right, what about the numbers 10 through 15? Those are two-digit numbers. So how can they be a digit in hexadecimal? Well, we represent those numbers as letters. So 10 to 15 are represented as A through F. So 10 is A, B is 11, C is 12, etc. So hexadecimal has the digits 0 to 9 and 8 to F. And in order to convert from binary to hexadecimal, you simply group the binary number into groups of 4 bits instead of 3, as we did in octal. So if you didn't watch the octal video, then please do that first, because this will make more sense if you do that. So to convert from binary to hexadecimal, you group it into groups of 4 bits. And then basically convert each group of 4 separately into their hexadecimal number, and then smush the digits together. So let's show an example. Say you wanted to convert this binary number into hexadecimal. You group it into groups of 4, then you convert each group of 4 into the hexadecimal digit, and then you just smush the digits together. So 1001010110 in binary is 256 in hexadecimal. So how about you try these problems and pause the video to work on it and unpause when you're finished or get stuck. Okay. I will show the answers and you can pause to see the work. Yeah, hope you got these answers. But yeah, for the sake of time, I'll just move on. So now let's say you want to convert from hexadecimal to base 10. You can use expanded notation, right? So A, 5e is equal to 10, which is just A, times 16 to the power of 2, plus 5 times 16 to the power of 1, plus 14 times 16 to the power of 0, which is 10 times 256, plus 5 times 16, plus 14 times 1, and then you multiply and then add, you get the answer 2,654. Now you can also do the table method. So let me show you. Right. Okay. So when we converted from binary and octal, so when we converted from binary, right? Remember in the bottom row, we put 1, 2, 4, and then we multiplied by 2 every time. In octal, we put 1, 8, 64, and then you're just multiplying by 8 every time. So that means since hexadecimal is base 16, octal is base 8, binary is base 2, that means hexadecimal, you want to multiply by 16 every time. So 116, 256. And then in the top, you just put the digits. So 256. So A is 10. 5 is 5. E is... B is 11. C is 12. D is 13. E is 14. Then you can see you multiply 10 and 256. Then multiply 5 and 16. And multiply 14 and 1. So you multiply the columns. And it's also the same here. And then you add them together, which is the same here. It matches up. Okay. So now I'll have you try some problems. Pause the video and work on it. And I'll show the answers now. Okay. Now we'll go on to adding and subtracting hexadecimal numbers. So adding and subtracting hexadecimal numbers is very similar to adding and subtracting other bases, except the only difference is that you need to convert the letters into numbers. No, actually, you don't even need to convert the letters. So you have two ways. You can first convert the letters into numbers, or you can just count. So I prefer the counting, right? What this means is this. You can see you have f plus 5. F is the maximum digit, so you have to add a place value, right? So f plus 1 is 1, 0. And plus 2 is 1, 1. Plus 3 is 1, 2. Plus 4 is 1, 3. Plus 5 is 1, 4. So This is 1, 4. So you put the 4 here, the 1 here. Now 1 plus B plus 1, so B, C, and then plus 1 again is D. You put D here. Now 6 plus C, you simply count, right? So C, D, E, F, G. Oh, sorry. Ooh, there's no G. C, D, E, F, 1, 0, 1, 1, 1, 2. So 1, 2. Ooh, what am I doing? 2 here, 1 here. A plus 1 plus 4. So A, B, C, D, E, F. It's F. So you can see you just get F to D4, basic C. Now subtracting, also the same thing, right? So except this time, when you borrow, you are essentially adding 16. So when you subtract, I like to convert it into numbers. So 5 minus F is 15. So let's say this is 15. Now F minus 15, right? Oh, sorry, no, 5 minus 15. You can't do that. So you have to borrow one from the B. The B becomes A, which is actually 10, but I'll just say it's A. Okay. And then 5 becomes actually 5 plus 16 because you borrowed you essentially borrowed a 16. So now you're doing 5 plus 16 minus 15, which is 6. Yep. And 10 minus A is 10, so 10 minus 1 is 9. And then 6 minus C, which is 12. So 6 minus 12, you can't do that. So this A becomes a 9, and this 6 becomes 6 plus 16. So you have 22 minus 12, which is, wait a minute. Yeah, 22 minus 12, which is 10, which is also A. Now 9 minus 4 is 5. Let's check our answers. Okay. Now you do some practice problems. Then I'll show the answers in 3, 2, 1. Okay, now on to the final topic today. Using hexadecimal numbers to represent colors. So computers use hexadecimal numbers to represent colors. Why is this? It's because hexadecimal numbers, you can make like a large number represented in the fewest amount of digits. So computers use a combination of red, green, and blue light to make colors, basically. And so a hexadecimal representation of a color is 6 digits. Okay, so the first 2 digits are used for red, the second 2 digits are used for green, and the last 2 digits are used for blue. Basically, you have a range from 0, 0 to FF. And that just represents how much of a color there is. So FF 0, 0, 0, 0 means that there's maximum red, 0, 0, maximum red, 0 green, and 0 blue. 0, 0, FF 0, 0 means that there's no FF amount of green, and no blue. And then the last 2 are used for blue. So this means that there's no red, no green, and FF amount of blue. And by the way, FF in base 10 is 255. Okay, so white is FF, 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 because in computers, actually, white light is a combination of every light, and then black is 0, 0, 0, 0, 0, 0, because black light is the absence of light. There's no light, so that's black. And you can see a bunch of other websites that a bunch of websites have like hexadecimal colors. All right, this slide should have probably been on the last slide, but anyways, yeah, so this hexadecimal numbers, these kind of build off these RGB colors. Yeah, so RGB is kind of a similar scale, right? You have three values. The first is red, second is green, last is blue, and it goes from 0 to 255. And this actually matches up with the hexadecimal scale because FF is 255, which is the maximum. So yeah, and using this representation system, there are a total of 16 million, almost 17 million different colors. So a lot of colors that can be represented using this system. So yeah, in terms of ACSL, I think colors, they come up occasionally. So yeah. All right, that's the end of today's video. And yeah, today we learned about hexadecimal numbers and also real world applications of hexadecimal numbers. And thank you for watching. And I'll see you next time.